Okay, here's another question. It's asking you that what's the pH of a solution? And when we do weak acid equilibrium, ultimately we're going to be asking you for pHs. Now, we can do ice tables until the cows come home, but one of the things that makes weak acid problems difficult is that you are often not just given the basic information you need and say go do an ice table. You have to remember what's going on from general chemistry. You have to remember stoichiometry. And so it says that you're going to allow 4.56 grams of magnesium acetate to dissolve in enough water to make 500 milliliters of solution. So what does that mean? That means you're going to have magnesium acetate and it's going to break apart into acetate ion and magnesium ion, but it's going to do that in this stoichiometric ratio. And what you need to remember is that if acetate is a weak base in and of itself, it's the conjugate base of acetic acid, so it's going to go around and react with the water. So once you make the solution, then acetate reacts with water to make acetic acid and OH minus. And this is the pertinent reaction that's going to change the pH of the salt solution. So what's the big difference here? In general chemistry 1, we just said, hey, we're going to make some salt solutions. Let's do some stoichiometry. But now what we're going to say is we're going to make some salt solutions, and some of those salt solutions will have weak acids or weak bases as one of the ions in the salt. And so now you're going to, let's go and think about the chemistry that's going to happen when we do that as far as equilibrium is concerned. And so this is the equilibrium reaction that's in play when we make a magnesium acetate solution. So we got some work to do. In order to figure out what the equilibrium is going to be with acetate, we have to figure out what's the concentration of acetate in the solution. And in order to do that, we have to do some stoichiometry. So we have to take the 4.56 grams of magnesium acetate, use the molar mass of magnesium acetate to get the number of moles of magnesium acetate. But it doesn't stop there. Once we have the number of moles of acetate, we have to remember that for every mole of magnesium acetate, there's 2 moles of acetate ion itself. And so that gets us the moles of acetate ion. But remember, we're still operating in concentrations, and so we have to divide by the volume of the solution in order to get molarity. It's not until you get the molarity that you can actually start doing the equilibrium problem. So you get 1.128 molar acetic acid, and we can do an ice table. We start off with 0.128. The water is a pure liquid, so none of that. So none of the acetic acid and none of the OH ion. It's going to go down by X for acetate, up by X for acetic acid, and up by X for OH. Equilibrium is going to be 0.128 minus X, X, and X there. Now what can we do? We need to figure out what X is in order to figure out the pOH, because the pH is going to tell us what the pH is. But look, what do we get in the problem? We're only getting the Ka of acetic acid, so we still have more work to do, right? Ka times Kb equals Kw. And so that means that 1.8 times 10 to the negative 5th times Kb, that equals 1.0 times 10 to the negative 14th. So Kb equals 5.55 times 10 to the negative 10th. Now that I have that, I can say 5.55 equals X squared over 0.128 minus X. And let's go ahead and let's try to make the assumption that X is small. And so I end up with 5.55 times 10 to the negative 10th equals X squared divided by 0.128. When I do that, I get X equals 8.43 times 10 to the negative 6. And so it is clearly small enough to neglect. So when I take the negative log of that, I get the pOH, because recall that X is the concentration of hydroxide it's not the concentration of H plus. So I get negative log of 8.43 times 10 to the negative 6. And so POH is equal to 5.07. Again, I have to remember that POH plus pH equals 14. So 14 minus POH equals pH. And so I get 14 minus 5.07. That equals 8.93. And let's round to 2 sig figs. pH equals 8.9. And that is the final answer. So a very straightforward 2-sentence question. Lots of work involved in order to get down there. That's one of the challenges with weak acid problems. You're going to need lots of practice in order to meet that challenge.